Okay, next one, we've got a ramp of a ship that has a weight of 200 pounds. Determine the cable force in CD needed to just start lifting the ramp so the reaction at B becomes 0. So I don't know if this is clear to you. I'm going to draw a free body diagram of this ramp right here. And I'm really going to simplify it, right? I'm just going to say, okay, there's my ramp right here. Now, normally I would have an NB, an FB, a B straight up, but this is a special case where it just starts lifting the ramp. It even tells you the reaction at B becomes 0. All right, so there's no force at B. There is a force in cable CD. There is a weight. Do you see that point G? There is a weight. If we have a weight, then draw the weight acting straight down from the centroid, from the center of gravity, or if it just shows it and tells it to you, then that G is where you should put the weight acting straight down. That should be straight vertically down, 200 pounds. Then we have a pin right here, so I'll call this AX and AY. All right. And then we've got some dimensions. This is 4 feet from here to here, 3 feet from here to here, 6 feet from here to here. The incline of the ramp is at 20 degrees. All right, what's this 30 here? What's this 30? That means that this is 60 degrees, not 60 degrees to here, but 60 degrees to here, right? Look at this 30, 60 triangle, so it's actually 40 degrees from the ramp right there. So it is, let me try to draw this. It is, because of this 30, that means that is 60. That is only 40 because that is 20, right? 40 and 20 and 60. Okay, now I think the hard part is figuring out, okay, how should I define my axes? How should I define my axes? If all else fails, I think I usually stick with the usual X and Y, horizontal and vertical, because unless everything is aligned along different axes, I think that will be easiest. All right, so let us sum the forces in the X direction. What forces do we have in the X direction? The force in cable CD, cosine 60, and AX equals 0. Two unknowns, so let me jump to my next equation. Sum of the force in Y. FCD sine 60, negative 200 plus AY. Still too many unknowns. So let me sum the moments. Where should I sum the moments about? I think it definitely should sum the moments about A, because then AX goes straight through it. AY goes straight through it. Those won't show up in my equations. 200, let's see, 200, and what is its moment arm? What is this perpendicular distance right here? That is 6, and so this is 6 cosine 20. 6 cosine 20. Creating a counterclockwise, so a positive moment, because I'm going to choose positive is counterclockwise. Then this force in the rope, now I could break it up into its horizontal and vertical, but then I'd have to take each of those components. Do you see that I could break it up into along the ramp and perpendicular to the ramp? This one along the ramp would be FCD cosine 40, and FCD sine 40. That one along the ramp would go straight through. That's why I'm breaking it up in this way, right? Because that one, FCD cosine 40, would go straight through it. But FCD sine 40, I can see clearly that its perpendicular distance is 9 feet. Let me draw it right here. I'm breaking this tension into those components using that 40 degrees because one goes straight through it. The other one, I clearly have the moment arm of 9. This one would create about a negative moment. Set that equal to 0. And so I can solve FCD 195 pounds. That one definitely should not have come out negative because it's a rope. Yeah, I know it has to be going in that direction. I can't break it into its different direction. I mean, it can't be pushing. I couldn't have chose the wrong direction for that one. Plug this in up here. I'd get AX is negative 97.5 pounds. What I want you to do, AX is 97.5 pounds. Maybe yours is cleaner than mine. That way. It's 97.5 that way. Plug this in right here, and I would get AY is 31.2 pounds. It came out positive, so I had drawn it the correct direction. 31.2 pounds. All right, so what do? Free body diagram. Some of the forces in x equals 0, some of the forces in y equals 0, some of the moments equals 0 to solve for 3 unknowns. If you have 3 unknowns, that's probably a good sign. If you have 4 unknowns, you missed something, or you can't solve this in statics. And also, if you have 2 unknowns, you may have missed something as well. Generally, most of these problems have 3 equations and 3 unknowns.